goodness. All right, so let's go to the class materials. All right, so open up the formulas and then open up the worksheet. Okay, so that's what we need. All right, so when you open up the concepts, this is what you have. Okay, it says lecture review material, so that's gonna follow the lecture for you. The problems are the ones that we will do in class, or I may assign some of these problems. Formula sheet is like that, and then if you just scroll to the very last page, you will have the conversions. Worksheet is the one that you need because I'm gonna format your solution, so it's gonna look like this. All right, so you can print this, or if you have a tablet, just plug it to the tablet so you can solve problems using the worksheet. All right, so what else do we have? That's pretty much it. All right, so we'll just focus on speed and velocity today. All right, so I'm recording the lecture. I'm gonna do a slight edit and then put them online hopefully tonight. All right, so the lectures go kind of fast. Try to take notes in the conceptual portion of it. The math portion of it, if you don't keep up with it, it's not a big deal. Go back and watch it and take notes. All right, because we got a lot to cover. All right, so let me just adjust the area. Okay. All right, so I got the recording area, so this is fine. Okay. All right, so observations. Okay, guys, once again, jump in anytime you want. Active participation is extra credit. You're on the honor system, so which means that you have to keep track of your points in this course. And then I will need your participation points at the end of the semester. So this is going to add up to an extra credit here, active participation. So speaking of active participation, who's the fastest person today?
Usain Bolt, right?
His name is Usain Bolt, right? Everybody knows who the fastest person today is. Okay, so who was the fastest person before him? Does anybody know?
Jesse Owens.
All right, Jesse Owens. So it wasn't Jesse Owens. His name is MJ. I'm not talking about Michael Jordan or Michael Jackson. I'm talking about Michael Johnson. All right. The funny thing about Michael Johnson, he had the world record in 200 meters and not 100 meters. Someone else had the world record in 100 meters. His name is Maurice Green. People endlessly debated who was faster. Was it Maurice Green or was it Michael Johnson? All right, so this commercial makes light of that fact. So is it Michael Johnson or is it Maurice Green? We will settle that debate today. All right, so let's talk about motion. Kinematics is what we're doing right now. Kinematics is the description of motion. And speaking of describing motion, what is motion? How do you know if something is moving? You know something is moving because it goes from point A to point B, right? So that's your measurable. You know it takes time for it to go from point A to point B. Also, you need to have something that moves, which means that you have to have a mass that's going to go from point A to point B. Now we got a complete definition of motion. Motion is displacement of mass in time, and in space. All right, so the motion is displacement of mass in time and in space. Okay, so what we need to do now is we need to describe motion in the way we measure. All right, and before we do that, what I want to do is I want to just go back here, and I want you to open up the concepts. Okay, notice that this follows the lecture. So this is where you end up taking notes. So the question is, what's motion? Motion is displacement of mass in time and in space. And then we're going to try to describe it in the way we measure stuff. So what are the only measurable quantities in describing motion? Measurable quantities in describing motion is mass, time, and space. All right, so it's going to be mass, time, and space. All right, so let's get back to the presentation. All right, so mass, time, and space are measurable quantities. So having said that, let's talk about mass, let's talk about time, and let's talk about space. The easiest one to talk about is going to be time. So what's time? Is time a human invention, or is it something that we get from nature itself? What do you guys think? Do you think this is something that we get from nature itself, or do you think this is a human invention?
I think the way we record it is a human invention.
All right, so which means that we get time from nature itself. How do you know that we get it from nature itself?
Well, don't like living things have like a lifespan? Like they like get born, then they die.
All right, certainly. I'm going to give both of you guys 5 points. Yeah, number one, you could experience the passage of time, right? I mean, something is born, it grows, it gets older, and then it dies off at some point. All right, that's how nature is. You have a small tree gets larger and larger and larger. Kitten is born, it turns into a cat, becomes older, and dies. Along the way, you start to get older, and that's how it is, right? All right, so there's definitely a passage of time. So time is something that's built into nature itself. Nature itself is cyclical, which means that the time goes in cycles. We experience 4 seasons because we go around the sun, and it takes a year to go around the sun. And then artificially, you can break it into months. Obviously, we got 12 of them, months into weeks, weeks into days, days into hours, and minutes and seconds. All right, so the way we measure time is an artificial invention, but the time itself is not. All right, so let's describe time the way we measure it. How do we measure time? We measure time using our clock, right? So Einstein came up with the best definition. He said the time is what's measured by a clock. So we'll go with Einstein's definition. So time is what's measured by a clock. So how's time defined in physics? Time is what's measured by a clock. So we will go with Einstein on this one. All right. What I want you guys to do is just pick out the best definition of time and just yell it out. Okay, so whatever it is that you guys are thinking, just yell it out. I need like 5 responses. A, B, C, D. Pick one of those.
I like the definition of A probably the most. The idea that time originates from cycles of nature itself.
All right, so give yourself the points. Guys, I need you to say A, B, C, D, or whatever. Just say something.
I
All
also
right, so
say
A, I got 2 A's. Okay. Where else? I need to have 5 responses before we move forward.
I like to say B for me.
All right, B. All right, so we got 2 A's, 1 B. All right, I need 2 more responses. All right, guys, I need 2 more responses. All right, so I want you to use the chat as well. All right, I want you to put your responses in chat, A's, B's, C's, and just make it simple so I can get an idea where we are.
B.
All right, so I got a B. All right, one more.
D as in dog.
Oh, D as in dog. Okay. All right. All right, so we got 5 responses. So I think we end up getting 2 A's, 2 B's, and 1 D. That's how it is. All right. So every single person who says something so far, give yourselves 2 points. All right. It's not bad. All right. So let's pick the best answer. So based upon the lecture that we are having, all right, the definition of time is what's measured by a clock. All right. So idea of time originates from sex of nature is not how time is defined, and certainly not a human invention. All right. So time is what's measured by a clock. So that's the definition that we will go with. So that's what Einstein came up with. All right. So those of you guys who pick B, additional 2 points for that one. All right, so moving forward, let's talk about space. What does space mean to you guys? When somebody says space, what does it mean to you? All right, so once again, we have to describe space. Space could be 1-dimensional, so it's going to have length. It could be an area. If that's the case, it's going to be 2-dimensional. And it could be a 3-dimensional, which means that you're dealing with something that has volume. All right, so Einstein, once again, is the guy who came up with the best definition of space. He says space is what's measured by a measuring stick. So what's measured by a measuring stick? If it's 1-dimensional, you measure a single dimension. If it's 2-dimensional, obviously you will have to measure 2 dimensions. If it's 3-dimensional, you measure all 3 dimensions, 1 dimension at a time. So that's what space is as far as Einstein is concerned. So notice that we're skipping 4, we're moving out to 5. Einstein says how's space defined. So I say how's space defined. So the best definition comes from Einstein. Einstein will say space is what's measured by a measuring stick, a yardstick, meter stick. All right, the last one is going to be mass. All right, so what is mass? All right, so what's mass? All right, so time is what's measured by a clock. Space is what's measured by a measuring stick. If that's the case, what do you suppose mass is?
The thing that a scale measures.
Okay, I'm gonna give you 5 points for saying that. You say mass is what's measured by a scale, right? So what mass is what's measured by a scale? I'm gonna give you 5 points for saying the wrong thing. It's not. I just set it up for failure on purpose. I gave you guys a pattern and you guys followed the pattern. Mass is not what's measured by a scale. What's measured by a scale is your weight. In deep space, you could be weightless, but you still have mass. On the moon, you may weigh 1/6 of whatever it is that you're weighing here, but your mass remains the same. All right, so mass is not what's measured by a scale. What's measured by a scale is your weight. And some of you guys are thinking, oh, if you have mass, you occupy a volume. That's not true either. Light is mass, and it does not occupy a volume. All right, so which means that the definition of mass is a little bit more abstract than the definition of time or definition of space. Definition of mass is rather old. It goes back about 350 years, all the way back to this guy Newton. And physics that we're doing right now is known as Newtonian physics. Mass, he says, is a measure of inertia. So it's a measure of inertia. Inertia is a combination of, inertia is the tendency of an object to retain its initial motion. Right, so if you're dealing with inertia, you're talking about a tendency of an object to retain its initial motion. Motion means something in Newton's definition. The motion means velocity. Velocity is a combination of speed and direction. All right, so velocity is a combination of speed and direction. All right, so once somebody is throwing definitions at you, the book definitions, it gets really, really confusing. And all of a sudden, the mass becomes something that you measure, but what you're measuring is inertia. Inertia is the tendency of an object to retain its initial motion, and the motion means velocity, which happens to be a combination of speed and the direction of that speed. All of a sudden, your brain is trying to figure this out, and then it gets confusing. All right, so what we need to do is we need to make sense out of this definition. So the mass is measure of inertia. That's what it is. Inertia is the tendency of an object to move in a straight line at a constant speed. And all of a sudden, I'm bringing a little bit more clarity to this. So the measure of inertia, so the measure of an object's tendency to move in a straight line at a constant speed is known as inertia. All right, I'm going to back out of this and then give you an example of it first. All right, so what's the difference between getting hit by a fly at 60 miles per hour, right on the face, and getting hit by a train at 60 miles per hour? All right, so getting hit by a fly is straightforward. So you take a hit on the face, and what does that feel like? It's going to feel like a slight pinch on the face, right? All right, so you will feel the pinch, and that's it. And you will think to yourself, oh, gee, I just got hit by a fly. All right, so that's the extent of it.
This is recording. So is he recording it?
He probably is.
All right, guys, I'm going to mute everyone. I'll mute yourselves whenever you want to say something. All right. All right, so you're getting hit in the face by a fly at 60 miles per hour. So what does that feel like? It's going to feel like a pinch in the face, right? That's the extent of it. You don't have to go to the emergency room. All right, you're perfectly fine. So the fly is going to come to a dead stop. So the fly is the one which is going to be dead. You're going to be fine. How about getting hit by a train at 60 miles per hour?
They'll like kill you, right? Like,
It's going to be a permanent out-of-body experience, right? All right, so a train is going to hit you at 60 miles per hour. And then it's going to keep on moving as if there's nothing there, because the train has a large tendency to retain its initial motion. It's going to keep on moving. Now, that tendency of the train to keep on moving and the lack of tendency for the fly to keep on moving, it's going to come from their masses. All right, so measure of that tendency is known as mass. All right, so that's measure of the tendency is known as mass. Now you have an idea of what mass is. So mass is, by definition, is the measure of inertia. So Newton is the guy who came up with that. Inertia is the tendency of an object to retain its initial motion, which means that it's the tendency of an object to retain its velocity, which means that the tendency of an object to retain its speed in the direction of that speed. All right, so the more massive you are, the bigger that tendency is. All right, so the train has a much bigger tendency to go in a straight line at a constant speed than a fly does, because train is a lot more massive.